Well, good morning, everyone. Thank you so much for joining us for June's edition of Health Bites with Region 3. We are so pleased to welcome this month's speaker, Marlo Brown. Marlo is a reference librarian at the University of the Incarnate Word in San Antonio, Texas. He's the liaison for the university's School of Mathematics, Science, and Engineering. His interests include freedom of information in the digital age and how libraries can remain relevant in the face of increased digitization of information. Thank you, Marlo, for being our guest speaker this morning, and we will turn everything over to you.
Thank you, Bailey. Good morning. I hope everyone is having a lovely day. We had some rain last night here in San Antonio, so I'm much happier than I was. And let me go ahead and share my slides. Can everyone see my slideshow? I think we can, right?
Looks great,
Okay.
Marlo.
Okay, thank you very much. So what we're going to talk about today is 3D printing. We're going to cover the basics of the technology, how it works, how you can get started, and maybe also make some recommendations of things that will probably work better for you than other choices. And right there is my contact information. I'm at the Mabee Library at the University of the Incarnate Word. If you visit our library, you can go to our LibGuides and you will find one on 3D printing that has a lot of the information that I'm covering today. It will also be in a link at the end of the slideshow. So in fact, pretty much all the resources I cover today will be listed at the end of the slideshow. And as I understand, yes, you'll be having that available as a PDF, and you'll also see it on screen if you wanted to take a picture at the end. You'd have all the links. And my email address is there as well, mmbrown1@uiwtx.edu. So let's talk about this wonderful technology, shall we, folks? So just before I get too far in, I do want to, again, here's my contact information. I've been in education for a long, long time. I'm relatively new to 3D printing, just a few years in. I came from academic libraries and also from computer science and technology services in a school district. So I've been playing with computers and related objects for a long time, and those are my languages there. I speak some Spanish. I can also do JavaScript, HTML5, CSS, LaTeX, and Scratch. All easy stuff, right? So let's get to the nitty-gritty. How does this work? And here we do see an example of an early prosthetic hand. It looks kind of primitive compared to some of the ones we have now, but it probably worked pretty well. And the cool thing about it was it would snap together. And one of the great things about this is it's such how to put this, such a democratic technology in the sense that most of the resources are free. The files are generally free. So if you get into 3D printing, you stand on the shoulders of all those who've come before you, and you're also given for free the tools to take it to the next step. So let's talk about how this stuff works. Today, we're going to be talking about a technology called fused deposition modeling, or FDM. Easy way to think of it is it's a hot glue gun controlled by a computer. And the nice thing about this is that it uses relatively inexpensive filaments. The filaments are really good. And once you get it started, you just watch and it creates your object. There are two kinds of printers that we'll talk about, and I'll get to them shortly, but they're referred to in slang terms as bed slingers and bed droppers. The picture here shows one called a bed slinger. What that means is the bed itself moves back and forth for one of the three dimensions, while the print head moves back and forth for another one of the three dimensions. And then the print head raises as it is printing to enable the third dimension, the Z axis. We'll talk about that in detail in a couple of minutes. The process that we'll be talking about is how a printout goes from a 3D picture, an STL file, to a 3D object. And there's a couple of steps in there, but it's actually relatively simple and relatively easy for someone, just an ordinary person, to do it. And we will also talk just a little bit about other printer types, but for the most part, we're going to stay with the FDM because the FDM printers, the squirters, the hot glue gun printers, are the most common, the least expensive, and the easiest to get parts for. There's more information about them online. They're really the best place to start. You may hear about something where it uses a liquid plastic, basically like a little tub of plastic, and the object rises out of that tub. It's really cool, but there's a lot of fumes. It's much more expensive. It's much more complicated. Yeah, it's better to start with FDM. So here's the process, and it's not that bad. It's what we start with is a thing called an STL file, and STL stands for stereolithography, which is basically a 3D picture made of triangles, little triangles. And the great thing about this is that a stereolithic file is free and available to you online. And there's a lot of repositories that provide access to that. And one of the biggest is a thing called Thingiverse. We'll also talk about a place at the National Institutes of Health where you can download thousands of objects. There are literally thousands of objects available to you as STL files. And one of the reasons they're distributed as STL files is that STL files are scalable. So when you are preparing it for printing, you can choose the size. If the thing is too big or too small, that doesn't matter. You can scale up, scale down without losing detail, without losing the shape. It's not like a picture online where if you scale it up, it comes apart. And what we do is we download an STL file, then we use a slicer program, and there's a couple of common ones. They're free. The most common are Cura and Prusa. I've been using Prusa for a few years, and that's the one that I don't necessarily recommend it. A lot of people love Cura. Either one of those two work great, and there's others as well. We use that to do a thing called slicing, and think of it kind of like a medical imaging program. It takes the object and literally slices into pieces like they're like say zero point 0.2 millimeters in thickness, and then it codes all of that in a thing called G code as a set of instructions, and that's how the printer actually prints it. Then you load the G code file into your printer and tell it to print. That's the simple explanation of the process, and it isn't that hard. It's pretty easy. So let's go a little further, shall we? And if you do have questions, please, yeah, use the Q&A and we'll do our very best to answer them as we go, especially if you don't understand something, some critical point that we're making here. So if you want to get started in 3D printing, how do you start? Well, you don't actually need to own a printer in some places, depending on where you live. And what I would do is I would go online in your area and type in 3D printing service or something like that. And there are commercial ones, they're expensive. But like here in San Antonio, we have a thing called Bibliotech, and they offer free 3D printing. You have to join their club, which costs nothing. They're mostly catering to young people, the kids, and I've visited some of their facilities during the club meetings, and it's like 10 or 15 kids are in this small room, all looking at computers and slicing objects and stuff. It's pretty exciting. It's fun. So the staff usually would assist you in slicing to help you be successful, and also to protect their printers, because there are settings in the slicers that could be detrimental to a printer. And probably the biggest one of those is the height of the nozzle. If you set the nozzle too low, it starts impacting the print surface, and you can imagine as it scrapes along, it could be damaging your print surface. And so what I do personally on my printer is I set my nozzle height on the printer and I never touch it in the slicer, and that way I know it's in the right place. They generally, free service will generally limit the number of free prints you'll get. One a month would be a common, thing to expect, one or two a month. And but the great thing is it's a learning opportunity. You're sitting down with someone who walks you through the slicing process. So you're not having to just figure it out on your own. Someone is guiding you through it, helping you slice it, and then helping you set it up for printing and explaining the process to you. So it's pretty cool. I really love the Bibliotech service. If you live in San Antonio and you want to try this out, you can try printing some small objects for free, which I think is a great deal. So why do we want to be printing this stuff? Well, what are the benefits of 3D printing? Well, if you're viewing this, you can see that one of the benefits is in the prosthetics field. That's a big one right now. simply because if you have any family members who have used prosthetics or needed a prosthetic, um, I have had a family member with a prosthetic, and that is a very, very, very expensive object. And 3D printing can bring that price way, way down, especially when you start talking about the fact that people who use prosthetics are often having to go through a series of them as their body shape changes a little bit, a stump changes, whatever. And every time they have to get a new one, it costs an enormous amount of money. But if they were 3D printing, maybe the price could be brought down. So what we do with 3D printers, all kinds of cool things. You can make unique or useful items, and often they can be made really cheaply in terms of the amount of filament, the price of filament. Typically, the filament that I'm recommending is a thing called PLA, and we'll talk about that in a few minutes. And PLA runs anywhere from about 20 bucks, 15, 20 bucks to maybe 30, $35 for a kilo for 2.2 pounds. And one thing about 3D printing, you will learn the metric system if you want to do it because it's all in metrics. It's all in millimeters and kilos and kilograms and grams and such. Um, but if there are replacement parts that you can't get, you can try looking for it as a 3D printer object. So say that you have an old vacuum tube radio from 1947, and the knob, the volume knob, is cracked and broken and has come off. It was an old Bakelite part. You could go and look for knobs for radios in Thingiverse and find one that would work, and go to a free service, print it out, and have and choose the color and have a knob that looks exactly like the one that was there originally. And have something that works instead of something that doesn't. Having a pair of pliers to change the volume is no fun. So that's one of the big things. Also, there's a lot of things. A lot of people think about toys. Lego is really a big thing in 3D printing. If you have anybody who is a big Lego aficionado, if they lose a few bricks and those were special bricks, they don't want to buy a whole set to get that specific brick. So they go online, they find the file, and lo and behold, they can print it. And they can print it in whatever color they want. So that's kind of cool. Big thing is that files are scalable. So you see, if you're seeing the picture again, there's a stylus grip there, and I have one here. Here's a stylus grip. I think you can see it that I printed. This is printed in PLA. It's flexible. It's very light, weighs almost nothing, but it is too small for my hand. So what do? I scale it up a little bit, take an educated guess, take a measurement or two, and I make a stylus that fits my hand and that could be used by me with no problems, even though my hand is larger than the original stylus was. And so it's totally scalable. It's the same object. It's just two objects that are the same object in two different sizes. And that's the scalable feature of 3D printing. The stylus that I was holding a moment ago, the idea of this is that if your hand is, say, has a problem, you don't have full control of your fingers for typing, you could put one of these on your hand and now you can type. Or you can use a palm a tablet or a laptop or a phone and use that as your stylus instead of your finger. So it's pretty cool. The one that you can see in the picture has a little rubber tip, which would be even better. The one I have here is just plastic, so it would be mostly for keyboarding. But you get the idea. That's a part that if you got it through a medical facility might have cost $100 or more for something that weighs, maybe 20 grams and cost me maybe, less than $1 to print. And yeah, it was easy too. The slicing software I've already mentioned is free, and it's actually very good software. And the filaments have just gotten better and better and better. When printing started, we did not have PLA. We had things called ABS and some others, which are okay. But now that we have PLA, I don't recommend them. So we'll talk about that. So if you're not sure about 3D printing, I recommend that you go shopping. And there's two websites here that I can recommend as a starting point, 3d.nih.gov. All of this is in the resources list at the end of the presentation, well, the two big ones. And in fact, I'll go ahead and link one of these in just a second. Let me go ahead and follow this Thingiverse one, or rather how about this visible skull from NIH? So if I click this, it'll take me to the National Institutes of Health. Come on, go, baby, go. There we are. And here is a visible human male skull. And unfortunately, they're showing you a view that may not be really representative of what most people think. But as we scroll down a little bit, we might see instructions. Here we see uploaded pictures of the skull, so we could click and see what the skull looks like when it's printed. And it's, anatomical. It's anatomically correct. Now, this is a finished printed skull. When you first print it, it's going to look a little different. We'll talk about that too. And frequently, here is where you would also see maybe some special instructions. It might have recommendations as to what filaments are most suitable, temperatures, things like that. And I would click download to download the files. And it's really about that easy to download. Now, when you get into slicing, there's a little bit involved, but it's not that bad. Thingiverse is probably the most popular place right now to go to for files. And here's an anatomically correct 18-piece magnetically connected human skull. So what you do is you print all these parts, and then there's little holes already placed in them, and you maybe open up those holes slightly, pop in some magnets that you purchase separately, and they recommend where to purchase them. And then you assemble it with the instructions that are in this set of files here. And if I scroll down a little bit, you see the summary information, and they describe how the thing works. And this really helps you make up your mind if you're not sure if you want to print this object. And talks about the magnets and how it goes together, and how some anatomical features have been modified to make it possible to print it and put it together. Some of the parts were too small to have magnets and therefore had to be fused to other parts and things like that. And then here's links to other things. Some of them like a flexible section of spine, all kinds of really interesting objects that for the medical field could be great, because some of these things, to purchase them could be quite expensive, and to have several objects that you could have, say, in a classroom setting, and allow students to handle and not be terribly worried that a really valuable object is being could be dropped. Because you can make another one if you have to. Now, a skull, actually, just to be honest, a skull takes quite a bit of time to print. Uh, let's see, I think I'm not full screen, am I? Let me see if
Correct.
okay, let me see if we can go up to a full screen. Hang on a quick second. Ha, now it's not letting me. Well, if it doesn't let me, it doesn't let me, but I'm going to try. Oh, now I'm doing all kinds of things. Let me try one more time, and let's see. No, it's not letting me do it. Oh, for some reason, it's messing with me. Let me try again. Oh, there we go. Okay, we're full screen again. Okay, my bad. Sorry about that. Not going to be surfing off to other things. That'll be my last field trip, so we'll just get back to where we were. Okay, so that's the shopping, that's available. And that's really what I tell people. If you're not sure if you're interested in 3D printing, if there's nothing you want to print right now, then probably this is not for you. The best way to find out if there is something you want to print is go shopping and see what you can find, see if there's something that you really want to have. And start looking for things. Just try typing, 3D Lego, for example, 3D print Lego, or whatever you were trying to do. So some of the possible use cases in the medical field or with the education would be, like I was saying, low-cost anatomy models or biological models. If you want to make a model of a molecule or a human liver, all kinds of things like that, you can print them. To make custom assistive devices like the stylus, for example, this would be an object that would be a real nice thing to be able to print for somebody, even if they were going to purchase a professionally made one, to be able to get one in their, on their hand and let them try it for a low cost and relatively low time. That's great. Custom fit prostheses, as I was mentioning, and I've watched videos of people who couldn't afford a prosthetic and they ended up printing their own at home. I don't know if that's as good as the professional one, but if that's what they can afford, and especially if they're, say, in a third world country or something like that, where they don't have access to the same resources. And rapid prototypes of new medical devices, doctors, medical researchers, folks like that who are trying to create new things might well be able to prototype in a 3D printer in a much shorter time than the usual time involved in making a mold, which is usually in the five figures to have a mold made for doing plastic molding, the metal mold, and you have to size it correctly because it has to allow for shrinkage, and it's much more complicated than people think and much more expensive. So 3D printing can be a nice alternative to that. So what's getting printed? Well, here's a picture, a close-up picture of a 3D printed bridge, very close up. And this is metal, obviously. And yes, people are printing metal. There's different processes, obviously, than squirting, like with plastic, but there are some similarities. There's some processes use a 3D printer to do a form to create the mold for something, to do the positive, the 3D positive, and then you make the mold by putting something around it, and then when the hot metal hits it, the 3D printed object dissolves and disappears and, goes away, and then the metal fills the mold, things like that. If you are familiar with the sintering process, which is called powder metallurgy, there are processes in 3D printing that use something akin to that, where it squirts it with a carrier and powdered metal, and then it's fused with a laser or fused in a kiln. So there's all kinds of processes. So there's some good things about this. This is what we call additive manufacturing, meaning that we build the layers, we just add to the layers. We're not cutting away like in machining. And the great thing about that is you can produce shapes that can't be made with machining, like a hollow sphere. Or immediately you can start thinking about shapes that are easy to make, say, squirting it, but not easy to make with carving away from a shape, from a block. Um, it can be a low noise, low cost, and low mess production method. You do have to be careful there. One of the things that really differentiates a lot of printers from one another is the noise level. I'm using one that's very, very quiet and very low mess, low cost, but not all of them fit that, and some of them are quite noisy. So you just have to do a little reading and a little studying before you make a purchase. Um, and some of the things are being used for today. I'll show you a picture a little bit later of buildings being squirted, but you can look that up and it's being done in different places. Think of concrete being squirted, and that's basically what 3D printing of buildings looks like. Uh, but again, they load a set of instructions into a machine, and there's a crane, and basically it looks like a giant 3D printer in a way, an arm and a thing squirting concrete. Medical devices, as we talked about, aerospace prototyping. If anybody has worked in manufacturing, you'll know that prototyping is insanely expensive and can be incredibly time consuming. And with 3D printing, you can make a part, see if it actually works properly and fits and functions before you go ahead and maybe prototype it in metal. And it can be used for metal squirting and some ships parts are being done that way. Uh, if anybody visits museum ships, um, around the country, a lot of those, they're very difficult to keep them afloat and functioning and looking the way they look as parts wear out, as parts break, as parts disappear. And so people who are working on, say, museum ships, they're building parts, sometimes in plastic, sometimes in metal, but they're building parts in 3D printers. And one really fascinating YouTube channel is by a gentleman named Ian Davis, who has been doing different iterations of a prosthetic hand for himself. He's missing fingers on one hand, and so he has invented a prosthetic hand that fits, that is 3D printed. And you really should you probably would find his YouTube channel interesting. He built the darn thing in aluminum first, and it's amazingly well made. But of course, that was heavy. So he wanted something that was lighter and more, could be modified more easily. And so he turned to 3D printing. Cool stuff. Oh, and one other thing that you can print is you can print a 3D printer. There's a picture here on this slide that shows it's from the reprap.org website. And this is one of the 3D printers that can be 3D printed on another 3D printer. So this thing can produce itself. You can buy a printer and make more printers. And in fact, one of the Prusa, which are very expensive printers generally, one of those can be, there's a model in the RepRap that can be printed. That's obviously for the kind of person that also builds their own drones and things. You've got to be really comfortable with the electronics, the mechanical parts, and assembling things. But a lot of the stuff is open source. You can buy the little motors and the stepper motors and the threaded rods and the hot end, the thing that heats the plastic, and the tube that carries the plastic, and the gears that move the plastic filament to the hot end. All that stuff can be purchased on the open market. You don't have to buy a whole printer to get it. So it's possible. So for starting out, a lot of people start out with this little guy that's shown on the slide. I have one here. This is called a benchy. This is a three-dimensional little boat. And why would you print a boat? It looks like you're printing toys. Why are you printing toys? Because this little boat can be measured and checked against the measurements that it's supposed to have to make sure that your printer is printing correctly, and also to see that your printer is printing correctly as far as the shapes. Like it has a curve, the bow section is curved. So if you're printing correctly, that'll be smooth and have a nice finish. If you're having problems, it could feel jagged here and you'd know that you have some adjustment to make. Does it have stringing? I don't see any stringing. This thing is nice and clean, but you can see the one in blue gray there has a little bit of what's called stringing, which is little threads, but it's because it's in a different filament and it didn't print as cleanly as the PLA one that I'm holding in my hands. The black one is PLA, and it printed beautifully. So this was a nice test, and you can do it in a relatively short time and see if your print is working properly. Another thing that people print when they're starting out is what's called a calibration cube. And this has letters and numbers on it that you can see, and to see if they're printed correctly. You can check it with a micrometer to see if it measures exactly the amount that's supposed to be. I think this is 20 millimeters. Um, and here's another calibration cube in black PLA. The other was white PLA. And like I said, you can look, oh, look, the Z is nice and crisp, the Y is nice and crisp. So it tells you if your printer is printing correctly. Are the corners sharp, the edges smooth? Yeah, that kind of thing. Cool stuff. That's how people start. Well, so let's talk about some, if you want to choose a printer, what do you buy? Well, I've suggested so far just FDM, which is Squirter, the most common, the most inexpensive printers. Um, there's two ways to deliver the plastic, the filament, and the filament looks like something out of a weed eater. It's a plastic filament. Most common is 1.75 millimeters in diameter, and that's what is generally recommended because it's the most common. And delivering it to the hot end where it's melted and squirted. There's two ways to do it, one with gears and one with a tube. And the tube has the advantage that the gears and such are not on the hot end, the part that's moving around, the print head. And the direct drive method, all that stuff is on the hot end, so it's heavier and technically it tends to be a teeny bit slower. It's a six and one half dozen of other choice. Both work. If you're going to be doing high temperature stuff, you have to go direct drive to get away from plastics because the Bowden tube is plastic. It's essentially Teflon, and it has a temperature limit. But if you're printing PLA, it'll work fine. Both work. Um, a heated print bed, that's a really nice feature. It's a relatively new feature. Only the last couple of years has it been available on a lot of printers. That is highly recommended because a heated print bed lets your model cool a little slower. It slows it down, and that way it doesn't tend to pop off the print bed like it might otherwise. And it also keeps it from deforming. The slow cooling allows it to maintain its shape. PLA is well known though for not warping as it cools, so that's a good thing. And all metal hot end, that's that direct drive thing. But if you wanted to print more exotic filaments, you would want an all metal hot end. I recommend staying with PLA unless there's a strong reason to go elsewhere. And then the bed slinger versus bed dropper, which one is better? Well, the picture here shows a bed slinger, and let me describe that in detail for you. A bed slinger works this way. There's three dimensions, X, Y, and Z, correct? Let's picture ourselves looking at a printer, and X direction is going to be left and right. The Y is going to be toward us and away from us, and the Z is going to be up and down. So you have to be able to move the print head effectively in all three directions so that it can, imagine it printing an object, and that object that's taller, the print head has to move up or the object has to move down. You have to be able to move in the the X and Y dimensions to be able to move to all parts of the thing to build each layer. So a bed slinger does it this way. The print head moves left and right. That's your X dimension. It runs on a rail, on a little wheel on a rail. And there's generally belts that enable this, and those belts are where you can have failures, so you have to always watch those. The Y dimension is handled by the print bed moving back and forth. And then the Z dimension is the print head rises as it prints the object. And so it's the rail that it sits on, the horizontal rail connects to vertical structures that have threaded rods, and that way it can lift the whole thing up as it prints. And so your print head keeps moving in X and rising up as the print bed is moving in Y. And that way you can manage printing a 3D object. And a bed dropper, the print head moves in both X and Y. It's in a box. Picture a box. And so the print head is set up so that it can move in both dimensions, X and Y. And then the bed drops away from it to handle the Z part, the Z dimension. And there's some advantages to each. Bed slinger tends to be lighter and less expensive and a little simpler. The bed dropper tends to be a little more expensive, but heavier, tends to have more structure to it. Frequently, they're covered in a box. They come in an enclosure frequently. And they're easy to enclose because they're box-like. You can just cover them in many cases. And in that case, one of the big advantages is since the bed is dropping and the print head is staying at the same height, if you want to run a camera and film your prints, say you have a YouTube channel and you're printing stuff and filming it, and then you're going to run a speeded up film, speeded up video, because honestly, uh, a small object like a benchy might take half an hour. A large object might take 40 hours. So you're not going to sit there and watch, but a camera could pick it up. And yeah, so anybody who's doing filming of print jobs wants a bed dropper. Bed droppers may also be more stable. Some people think they're more accurate. Um, it's just a matter of preference, really. Um, I would go with a recent model of printer. The Ender 3 that's pictured here is considered an older printer. That's maybe a 4 or 5 year old technology. But I would look to it for one thing, and that's the basic size. I would have no smaller than that, which is 220 by 220. That's your X and Y. That's the size of your print bed. And your 240 is the height. That's how high the print head can rise, or the print bed can drop, depending on the technology you're using. But 220 by 220 by 240 is the minimum. Mine is a 240 by 280 by 300, so I can print something that's 300 millimeters tall. 200 millimeters is about 8 inches, so 300 is about a foot. So I can print an object that's a foot high, 8 inches wide, over 8 inches wide. You get the idea. Yeah. So, and open source or not, what is that? Well, open source means that the parts are available on the open market. The advantage of an open source, like an Ender, they're open source, and there's a lot of rebranded printers. I bought a different brand, but effectively it's an Ender. When I take it apart and I look at the board inside, it says Ender on it. They're open source in the sense that I can buy those parts on the open market from a variety of vendors. A non-open source, a classic example is Bamboo, which are very, very good printers, but they run about $1,000, and you can only get parts from Bamboo. Software comes from Bamboo. It's kind of a closed system. It's sort of like Apple, in the sense that Apple, you don't buy a lot of aftermarket stuff for Apple, and it's kind of the Apple versus Microsoft sort of thing, or Apple versus Linux. That's a better example. So what about setting up a service? If you were in a library and you thought, we want to be able to offer printing. Well, if it were me, I would go someplace like Bibliotech and look at their rules and maybe call them and talk to them. Or find some other library that's doing it and ask them, what has worked and what hasn't, because you don't want to reinvent the wheel. I do have some suggestions, and one of the biggest one for me, the biggest two actually, are one, only the staff operate the printers, because printers are rather delicate, and if someone starts messing with them, you can imagine you could have problems pretty quickly. The staff would help the patrons select an item and slice it. That way, you control what gets printed. One item per month per patron sounds like a reasonable limit, or maybe you'd have a different limit, but something like that. You would want to limit the kinds of objects that people might not be able to print. You can think of some examples, I'm sure. By the way, probably Thingiverse has all the stuff you don't want to print in addition to all the stuff you do. So just be aware. Yeah, someone can find things. Get a middle schooler to look for them. They'll find all the bad things. Um, you can set a limit in grams of the amount of filament that an item can have. That'll effectively control the time it takes to print in a lot of time, in many ways, and also just the amount of filament that you're burning up on one object. And you can say, we'll have the object, say, in 72 hours, so many days, whatever. And then the patron has to come pick it up. And I would recommend that you have only PLA filament and only regular colors because they do have like silk and other things. Those are much more expensive and a little trickier to work with. I would offer several simple colors, black, white, orange, red, blue, that kind of thing. And once you get going, maybe do some printing and start putting it up on the website to show the kinds of things that they can print. Things like, figures for games, um, objects. Like I should have brought it with me. I have a Darth Vader pencil cup, pen and pencil cup on my desk. But all kinds of fun objects. Here's a fun object. This is a doorstop, printed 3D printed doorstop. And the great thing, if you can't see it, it's a teardrop shape and has a big hole in one end, so it doesn't use a lot of filament. And that hole also allows it to go on if you have the handle type door, not the knob type door, this can go onto the handle so it's not laying on the floor when it's not in use. And it's quite sturdy. I cannot break it with my hands. It's held up. I've been using it for months. I can't break it. It's a nice, strong object. And it wasn't hard to print. It was kind of fun. So an example of something that could be printed. And yeah, so you could have pictures of a lot of the objects that people have printed. TIE fighters, from Star Wars, or all kinds of fun things. Spaceships and toys and uh, useful objects, just things that, like if someone has a tripod for their photography work and one of those little plastic parts breaks, you can go on Thingiverse and look for it. And if you have a name brand, a common brand of tripod, there's a good chance that someone else has already printed those objects. And if they haven't, there is such a thing as CAD software available to you that you could get for free and learn how to use, and you could design your own. So what about filaments? I recommend PLA to start and probably to stay with. Its only real drawback is if an object is going to be over 140 degrees, PLA will start to soften and deform. And so as long as you're not leaving it in your car, as long as you're leaving it in temperatures that you are able to withstand, it'll be fine. So if it's going to be inside your house, it's not going to be a problem. I would not have PLA for an object that's going to sit outside in the sun. It's probably going to change color and the heat is going to melt it eventually. So at least you're in Texas. There are other filaments. PETG is about the only other way that I would go if I wasn't using PLA. PETG, here's an example of a PETG pen in blue-gray. It was not hard to print. It looks fine. If I left it on the dashboard of my car, it would melt, but sitting inside out of the sun, it would not melt. And yeah, not hard to print. I'll show us a few broken toys in just a second to talk about. Well, I guess this would be a good time actually to talk about failures, huh? So PETG is harder to print than PLA, but it's a little more heat resistant. That's probably its biggest advantage. Others, nylon is exotic. You almost need to buy a printer designed for nylon. If you buy a simple, inexpensive printer and start printing nylon, you're going to wear it out really fast because it has to print at very high temperature and it's going to give off fumes. Yay. PLA, I should talk about a little bit as far as what it's made of. This stuff is made of cornstarch or sugarcane. So basically it's natural, it's biodegradable. I wouldn't recommend eating it, but it will biodegrade and it can be recycled. And frequently you can buy PLA that is recycled if that's what you want to do. So let's talk about failures. Here's a broken pen. When you are slicing your object, you have to decide how it's going to be positioned. And when I was reading about this one, they were recommending print it vertically. So I printed it standing on end. And what that meant was that all the layers were running across. And so I picked it up, held it for a second, gave just a tiny bit of force, and it snapped into. Yay. So if I print it laying down, it's totally strong. I can't break it easily. I could probably break it if I tried really hard, but it's at least as strong as a commercial pen. And it works. It just meant that I had to clean it up a little better. It had some support materials, and I'll show you supports in a second. I don't recommend nylon unless you buy a printer for it, and I really don't recommend ABS. Someone will probably chirp up at some point and say, but ABS is used to make Legos. Yes, it is, but they don't 3D squirt it. It's not easy for the home hobbyist. It gives off some really awful fumes. Here's three printer slicing softwares that I can recommend. Cura, I've tried. It's great. A lot of people use it. I switched to Prusa. I just like the interface a little more, but they do the same thing. It's like two brands of word processor. And Orca, again, similar. It comes from Bamboo. It's good too. I mean, you're not going to go wrong with either of those first two, really. Either Cura or Prusa Slicer, both of them work great. I don't have any real experience with Orca, except I've heard good things about it. And here's what an object looks like on a slicer. This was an object I made for some physics professors. They were experimenting with some cryo materials, and you can see the object. You can grab it with your mouse and spin it around. So when you open an object in a slicer, this is what it looks like. It'll either be blue or green, probably, at least in Prusa. And I can spin it in all three dimensions. I can even rotate it up and look at it from below. And this is the the STL file at this point. And then what you do is you set your settings and you slice it. And you can see there's lots of settings. There's a couple of things that you'd want to be, you can set the amount of infill, meaning how solid the object is. Um, like for example, my doorstop, I made it fairly solid. I think I went about 75%. So there's about 25% air inside here. If you make it too much infill, too little infill, it could be weak. If you do too much, then you end up spending more filament and spending a lot more time to print it for no reason. So you have to kind of judge by what the object is. Like a pen, you'd probably go 100% because you don't want, a pen, everything is really thin. The walls are thin. You wouldn't want air inside the walls. You'd want them to be solid. So yeah, that's the kind of decisions you would make. If it's laying down, if it's on the surface and something is overhanging, like say, show you an example. There's support material. Here's what support material looks like. This is a dinosaur skull with the support material still in place, a little tiny dinosaur skull. And this is a kind of support material called organic. That's why it looks like something out of a science fiction movie, like it's Stephen King and Creepshow being taken over by the plant. And what you have to do after you print it, this keeps it from collapsing. When the plastic is hot and it's being squirted, if it's overhanging, sitting off in space, like the arm of Spider-Man in a figure, say, if there isn't something supporting it, it's going to collapse before it gets a chance to cool. So you can kind of think of it in layers. This prints the support material along with everything else all at the same time. And then when you have your finished object, you go and remove all the support material. It's supposed to be easy to remove, and it generally is. And you use something like a pair of nippers to remove it. And then usually I have a few tools. I use this little guy here. This is a little tiny, sturdy knife. Here, put it in front of, there we go. You can see it now. This is what's called a kiridashi. If you looked for a thing called a neck knife, the idea of a tiny fixed blade knife, that's probably a good choice for being able to pry and cut and such. Utility knives are a little too fragile. Pocket knives are a little too fragile for that. You could break a blade. But generally, if you're using a lot of force, you're doing something wrong. And so I snip away all the extra stuff. Sometimes a pair of needle nose pliers is good for reaching in and pulling filament out of holes where it's holding something open and making it possible. But you can see this whole thing is just, there's tons and tons of filament here that was used, and all of the support material is hollow. So, but you have to allow for that when you print. And here's what happens if you don't. If you don't have enough printer filament on your printer when you start a printout, it ends and you haven't finished the job. And this is a partial dinosaur skull. You see, all I got was the jawbone and some support material, and it stopped. And so what you do is when you're in your slicer, slicing your object, you can see how much it's going to weigh in terms of both the support material and the object, and you can figure out if you have enough on your spool. And you might say, well, how do I know if there's enough on the spool? When you get a new spool of filament, immediately weigh it. If it's a kilo of filament, that's 1,000 grams. So whatever it weighs, say so it weighs 1,200 grams, and you subtract 1,000, and you find out, wow, my spool weighs 200 grams. So it usually is lighter than that. And so then you know that if, say, your spool right now weighs 1,000 grams, then it has 800 grams of filament. And when you check your slicing program, it might tell you need 1,300 grams of filament for a particular object, or 800, and you know if you have enough to print it. So not too hard. And slicing software is not too hard. Like I said, joining, finding a library that helps people print would be a great way to learn the slicing software. And the slicing software is going to be free, but you set things like your layer height. That's going to help with how much detail you have. You set your filament infill so that you know how hollow it is. You can size it. You can see in the lower right-hand corner of the screen, it shows the scale right now at 100%. If you change it to 200, it's going to be the exact same object, just twice as big. It's not going to change shape. And you can set the kind of supports, if you're going to have a support or not. And frequently when you download an object, it'll tell you what you need. It'll tell you what temperature you need, what support you need, etc. Thingiverse is really good about that. A lot of the people who post there give a lot of detail to tell you exactly what you need to have for your object to be printed correctly. And they recommend kinds of filament. It's really very helpful. And you can open up the object without printing it in the software. You don't even have to have a printer to have the software. So if you were saying, well, I want to be able to print a particular object, then open that object in slicing software, and they'll tell you how much space you're going to need. You can see the little brand name on the printer surface on this image. And so this software is sized for my printer, is set for my printer. And so you could open up something like Cura and say, well, I want to be using an Ender 3. And so it would find those dimensions and set up that profile, and then bring an object in. And if it's hanging off the ends of your surface, you know, oh, this one can't be printed on an Ender 3 unless I scale it down. For examples of big objects, if you see people in stormtrooper armor, some of that is 3D printed. Not all, a lot of it is vacuum formed and other methods, but some people are printing stormtrooper armor to be Star Wars nerds. So if you want to be a super Star Wars nerd, that is one road. Some people have home businesses where all they do is print helmets. They have very big printers and they print helmets for cosplay. So home business, hey. So hints for success. Probably the biggest thing that's going to determine whether or not you can 3D print is, do you have a do-it-yourself attitude? If you are one of those people who goes to YouTube and looks for videos to find out how to do something, that's a good indicator. If you want it all to work without having to do anything, this may not be a hobby for you. Because even if your printer works perfectly the first day, you still will have to maintain it. And maintenance, it means things like lubricating the rods that move the print head up and down, checking belt tension, maybe putting a drop of lubricant here or there on different parts of your printer, cleaning it, vacuuming it. If you want to enclose it, you can 3D print the parts for enclosing your printer. Some people use, by the way, there's an IKEA table, and they buy one table, they put the printer on top of it, and put the other printer on top of that, the other table on top of that, and then they just have to close off the sides of the table. Yeah, those are things. If that sounds like something you would do, then yes, this might be a hobby for you. If you want to set this up in a library or some other facility, you need someone who does have that attitude, and it's going to be the 3D printer honcho. Use P3 use PLA filament because PLA is the easiest to print with. It's strong, it's inexpensive, dozens, hundreds of colors available, lots of colors available, lots of brands. I have used Polymaker PLA with great success. I recommend it. It's highly recommended all over the place, and it's easy to find and not expensive. Um, and then three things that you can do to make sure that your prints are good. One, you have to have a level print bed, and that's not level with the floor. That's level in regard to the rest of your printer, so that as the printer head moves over the surface, it's at the same height. If it's trying to move at the same height, it can. And if the bed is at an angle to it, then you can imagine that would make it much more difficult to print. Now, there is such thing as auto leveling, but that just allows for slight imperfections. You still have to learn how to level a print bed usually. And there's videos that walk you through it, and I have one recommended in my resources. Setting the correct Z offset, that's your nozzle height, and then learning how to prepare your print bed. PLA is easy to print, but there's different things that you can do to prepare your print bed for PLA. The big thing with PLA is you want it to stick to the bed. That's the hard part. With a lot of the others, it's getting it off the bed later without destroying the print bed. So what I have to do for PETG is put a layer of tape, like painter's tape, and then glue stick, the purple Elmer's glue stick. That's how I prepare it. YouTube's your friend. There's a picture of a printed house that's being made with squirting cement. You can see it's like a giant 3D printer. They create a scaffolding, a gantry type arrangement, and then the print head delivering the concrete is able to move and rise up and print a house. And then they can go in and put all the stuff inside. And here's resources for printing, 3D objects. If you did nothing else with this, today, if you took a picture here, you would have, or a screenshot, you would have pretty much all the links. And the Wikibooks 3D printing book is actually quite good. There's links to all your slicing programs. There's my LibGuide, and there's links to NIH 3D, which is really a great site, and Thingiverse both. Yeah, all kinds of fun stuff. And are there any questions? Have we gotten any questions in the chat, in the Q&A during this?
Marlo, yes, we have. We have a few questions here. I do want to
Awesome.
acknowledge we have 5 minutes left in the hour. So here in just a couple minutes, I'll put the link to claim MLA-CE. But in the
Great.
meantime, we can go ahead and go over a couple of the questions that have gone into the chat. You addressed this a little bit, but one question asked, is there a way to create our own STL files? Is there an app for that? You mentioned CAD.
Yes,
Did
yes,
you have
yes,
anything
CAD.
else?
It's CAD. With CAD, you would create a shoot, what's the CAD files called? It's escaping me right now. But there's free CAD software available, and again, you can do some searching. Actually, if you go to Wikipedia, you can. I remember seeing a list of a bunch of CAD software, and it talks about what it can input, what it can output, and if it can output an STL file, then you're good, you're gold. So yes, there are people who visit museums and photograph objects and then take that into the software and create STL files of like pieces of artwork, three-dimensional artwork, and then they print their own versions of it. Yes,
It's
yes, there is
fascinating.
software. Yeah, CAD software is your friend, and there's YouTube videos and there's Wikibooks that talk about how to use that stuff.
So there was some interesting conversation about this in the chat, but I'll go ahead and bring this up. You were talking about Lego, and
Yes,
so a question arose out of that. Are there any copyright issues if you replicate an item?
that is something I have not explored, but of course there would be. Now, if you were doing it for fair use for your own, like replacing a part, I don't see that you would likely get sued by Lego. I mean, it might not be, it may be in a gray area, but would you get sued by Lego? Now, if you began making Lego parts and selling them, I could see that you could easily have Lego's lawyers come knocking on your door. So I would not be too worried if I was doing something for my own use to replace a lost part or to fix something that didn't quite work right. But Yeah.
I think that's
Uh,
that's a great point, and I think that's what someone mentioned in the chat is that if it's for personal use, that's one thing, but if you start using it for commercial use, that's something else entirely.
yes. Are
So,
you selling your creations? Then you need to talk to Lego, or you need to just make stuff yourself. Create it yourself. If you're creating it in CAD, I don't know how Lego's patents are. That's a complex legal issue.
I love this question, and this person appears to be someone who has worked a great deal with 3D printing. So the question is, what has been your most exciting or rewarding project that you have worked on?
Oh, I have it right here. We can talk about spectacular failures. This is a spectacular success and failure. This is a human skull that I printed. Can you see the problem our friend has? If I get close, can you see that the top of the skull is shifted over just a little bit? This is what happens when someone bumps a printer while it's printing. The printer does not have feedback and it doesn't realize where the print head is. So it looks great. I'm going to have to take a razor saw and cut this free and then shift it over and glue it back. But yeah, this I really always wanted a skull on my shelf, and I have one now. But unfortunately, it looks like I cut it and put it back together wrong or something. Yeah. That's also why you wouldn't want your printer out where the public could touch it in a library, because if they bumped it, also if your belts got misadjusted. But that's been my most rewarding project. It was so much fun to watch it print.
Marlo, we're here at the end of the hour. I did put the link to claim CE in the chat. There are three more questions. Would you mind staying over just a couple of
Oh,
minutes
of
to
course.
answer
Yes,
those?
I'd be happy to.
Wonderful. So, you did talk about this a little bit. Someone does ask, what about the issues of cleaning PLA, especially if you are printing a lot of objects?
Good question. When you say cleaning, you mean removing the support or cleaning the printer? Because both of
I
those
think
are
it was when
equal.
you were talking about the supports that this question
Okay.
came up.
Yeah, my printer came with a little set of nippers, and Home Depot, Lowe's, they have, you can buy like little nippers, like a wire cutter, a small wire cutter, like for electronics would be perfect. Or even, like a toenail clipper, something like that. Just a small, strong clipping tool. But I think I'd go with a pliers type, a wire cutter, a small wire cutter, if it wasn't provided with the printer. And then this object here, this little tiny knife that you can see is also useful because I can use it to pop away little bits of filament and also reach into holes. The other tool that I would really strongly recommend if you have anything that has holes in it that you want to be able to clean up is a thing called a pin vise. That's the word, pin vise. And it clamps onto a drill bit. It has a handle. That's it. So you're holding a drill bit with a handle. I don't recommend using a powered drill because if you go to try to drill into an object to open up that hole that's almost perfect, it can grab the plastic and rip into that object and destroy it in a few seconds. Don't ask me how I know. Um, and so what you want to do is use a pin vise so you could just very carefully ream out holes. That makes sense. And a pair of small needle nose pliers are also useful. And then as far as cleaning up PLA in your printer, a small shop vac, something that has bags as opposed to a filter, because you have little tiny bits of plastic that'll probably clog a filter vacuum. So I'd get one that uses bags, and I would vacuum frequently because there is like a fine dust. And that's a good argument right there for enclosing. Even though PLA is non-toxic, I don't want to breathe the fragment, so I think I'd enclose it or use it in a large open area.
Thank you. So this person says, I'm moving to Fairbanks, Alaska next
Oh,
month.
yay.
Wow, that's exciting. Heat is less of a problem than cold. Are PETG or PLA subject to breakage in cold temperatures?
Probably, but I have not tested it because it doesn't get cold enough here to find out. But you could easily Google PETG, and PETG is basically water bottle plastic with glycol. That's what the G is. PET is water bottle plastic, and it's naturally clear. And so if that stuff cracks in the cold, then PETG will crack in the cold. PLA, it doesn't seem to have many vices, so I don't think cold would be one of them. But you would have to find out. Maybe print something and put it in your freezer and see if it becomes brittle.
a great suggestion. And then right at the end of your presentation, you did talk about this a little bit. What's your recommendation for adhering the first level print?
Well, that there's a video in there in my presentation by a guy who calls himself Dr. Vax, V-A-X, Dr. Vax, and he has a thing about print bed leveling. You can also tell you honestly, a lot of the providers will provide suggestions. What I use on a print bed is I get it super clean. I scrub it with soap and water like Dawn. I scrub it. I use a what's called a oh, I don't remember the acronym, but it's basically it's a textured metal print bed and it's magnetic, so I can pop it off and clean it, take it over to a sink and then scrub it real good with Dawn. And I just use like a paper towel or something. And then when I'm ready to print, I'll wipe it down with rubbing alcohol, the high alcohol, like a 70 or 90% alcohol. And then I spread a thin layer of Elmer's the school glue, the non-toxic purple school glue glue stick, just a thin layer of that, and maybe I'll take the cap and just smooth it if there's any high spots, and that's my print bed. And it sticks pretty well to that. If I did that with PETG, I'd destroy my print bed because I wouldn't be able to get it loose. The layer of tape that goes under the glue stick for PETG allows it to be done. So this is PETG. I never would have gotten it loose if I'd done just glue. I had to do tape. Then it comes off, and sometimes you have to peel the tape off it.
And then real quick, one more question that came into
Sure.
the chat. Where do you take your scrap PLA? This person's trying to recycle theirs, but hasn't had much luck finding a place that will take it.
That's a good question. It would depend on your local. I would talk to recycling centers locally and see who would take it. PLA is pretty recyclable. It's natural. It's organic materials, so it's non-toxic. It should, it'll biodegrade with time. So yeah, I would call local recyclers and ask them.
Wonderful. Thank you, everyone. Excuse me. Thank you, everyone, for these just wonderful questions, for all the interaction in the chat throughout this fascinating presentation. And thank you also especially to Marlo Brown for sharing your expertise with us. We look forward to seeing everyone here at at next month's Health Bites with Region 3. Thanks again, Marlo.
Thank you.